Select. Alright, so this weekend you guys did some work on inverse functions. You did some reading, and maybe it didn't happen this weekend. Maybe it happened this morning on the bus. Maybe it happened between period 1 and period 2 passing period. I don't know about these things anymore. What I know though is you have been exposed to inverse functions in Algebra 1, in Algebra 2, in pre-calculus, and now here it comes in AP Calculus. This is one of the last topics that we're going to talk about. And here's the important thing I need you to know, that that's time for me to take attendance. Yes, that's the important thing. When we talk about inverse functions, like for example, the inverse of adding 3. Oh, so awkward. The inverse of adding 3 is subtracting 3. And the inverse of multiplying by 17? Dividing by 17. And the inverse of squaring something? False. Squaring something doesn't have an inverse. Oh. Right? The issue with squaring something, when I, if I said, take the number -6 and square it, you're going to get 36, right? If there was an inverse, there'd be an operation that would guarantee you that you get the exact same number back. And you all said square root, and the square root of 36 is positive 6. Squaring does not have an inverse. Multiplication has an inverse, we call that division. Adding has an inverse, we call that subtraction. Squaring does not have an inverse. Everybody okay? But this idea of a function and its inverse, I used to, when I took a course in topology in graduate school, God, I hated every single minute of that. But here was the idea. You had these blobs. This blob over here was your domain. This blob over here, where's your range? And before you ask, where do I put these notes? I don't care. Domain and range. A function, f of x, assigns to each element in the domain a range number. Right? This is hopefully our understanding of a function. There is an input. You put that input into the function, you get an output in the range. The inverse reverses this process. So if, for example, I said the number 3 gets mapped over to -5, then that would tell me that the inverse would take -5 and map it back over to 3. We're okay with this? All right, good. This is the idea of a function and its inverse. Now, in the event that I actually have truly found the inverse, then it has to be true that if I say find f of x and compose that with the inverse, what I'm going to get back, I take x, I plug it into f, that gives me some output, right? What does the inverse do? The inverse spits back the original number. So we would say that f inverse of f of x equals x. It has to work in both directions. It has to be true that f of f inverse of x also gives you x. It has to work in both directions or they're not truly inverses. Big picture, are we kind of okay? Yeah. So here's what's going to happen in calculus. We're going to start talking about derivatives of inverse functions. And this is where the brain needs a little bit of rewiring. So rather than use this f inverse notation, because you know what's going to happen in a calculus class? You're going to get it confused. You're going to get confused with something. You're going to get confused with derivative notation. We're generally going to avoid f inverse notation because we have the prime notation that sometimes gets in the way. So instead what we're going to say is we have two functions f and g which are known to be inverses of each other. If you know that f and g are inverses, then it must be true that f of g of x equals x and g of f of x is equal to x, that they have that inverse relationship. You put an input into g, you take that output, you plug that into f, you get the original input back, and in the reverse direction. Alright, so there's a relationship that I care about. Let's start with what we know. We know that f of g of x is equal to x if f and g are truly inverses. What I want to do is I want to take the derivative. So let's take the derivative. What do you guys know about the derivative here? Chain rule, right? F of g of x. If I'm going to take the derivative, I need chain rule. And the chain rule tells me, take the derivative of the mama, leave the baby alone, times the derivative of the baby. Now keep taking the derivative. Take the derivative over here on this side. The derivative of x is 1. So, is everybody okay with this opening relationship? F of g of x is equal to x? And is everyone okay taking the derivative? With the chain rule, f prime of g of x times g prime of x is equal to 1. Well, often, you're going to know something about f of x. This is going to be like the given function. And they're going to ask you stuff about this guy here. So this is the inverse of f of x. When that happens, what you can do is you can use this chain rule relationship to say, well, if f prime of g of x times g prime is equal to 1, then it doesn't have to be true that g prime is equal to 1 over f prime of g of x. F is the function that they're going to tell you stuff about. If they've told you stuff about f, you should be able to find f prime. But if what I want to know the derivative of the inverse function, I'm going to use this relationship that honestly we just proved using the chain rule and using our definition of an inverse. This guy here would be the new thing to add on to your foldable. That if f and g are inverses, then g prime is 1 over f prime of g of x. I know, it's thrilling. Thrill a minute. Poor Lewis. All right. Flow. If you want to update your derivative foldable, feel free to do that. I would maybe write on one side like inverse, and then do the folding thing so you get to the blank part. And then you can write if f of x and g of x are inverses, then this guy has to be true. All right. So let's look at a model problem. Let f be the function defined by f of x equals 1 over x cubed plus 1. Okay, a function. If g of x equals f inverse, so now they're telling us like g is the inverse. We've got the inverse relationship that I'm looking for. Inverses. And g of 1/2 equals 1. What's the value of g prime of 1/2? F is the function that they've told me about. G is the inverse of f. G prime is what we're trying to find. We're trying to evaluate g prime of 1/2. This is how these inverse function problems are going to work. Everybody mostly okay? Well, let's kind of blindly go along with this. If we know that g prime of x is 1 over f prime of g of x, then for me to find g prime of 1/2, I need 1 over f prime of g of 1/2. Right, g prime of 1/2 is what I'm after. This is the derivative relationship that we just proved. I need 1 over f prime of g of 1/2. Anybody know what g of 1/2 is? G of 1/2 is 1. They gave me that information in the beginning. So all I really need now is 1 over f prime of 1. To figure out g prime of 1/2, I need to take the reciprocal of f prime of 1. Do we know what f is? Do we know how to find f prime of x? Do we know how to find f prime of 1? Okay, finish it off. I'm going to take you 10 minutes. our quotient rule. Quotient rule works. There's another option here. I could look at this as a chain rule. If I see 1 over x cubed plus 1 as x cubed plus 1 to the negative 1 power, that might make finding the derivative a little bit easier. So you would bring that power down, subtract 1 from the power, multiply by the derivative of the inside. You're going to get negative 3x squared over x cubed plus 1, the whole thing squared. Does everybody get the same derivative? Whether you do quotient rule or chain rule here, it's going to be the same thing. This isn't the answer, though. I need f prime of 1. F prime of 1 is going to be negative 3 times 1 squared. 1 cubed plus 1, the whole thing squared. Is that negative 3/4? If that's your derivative, you plug in 1, you're going to get negative 3/4. Negative 3/4 is not the answer. Why is negative 3/4 not the answer I'm interested in?
Because that's g of 1. I mean, that's
That's f prime of 1, but what am I really after?
g prime of 1.
Right, this is giving me derivative information about the graph of f. What I want is derivative information about the graph of g. This is like an intermediate step that I'm doing off on the side. So your final answer is really the reciprocal. It's going to be 1 over negative 3/4, which is negative 4/3. Is everybody okay? Okay. Good news is there's not going to be tons of these inverse questions that we're going to do. It's like one question on every single AP exam. But really, it all starts with, if I know this inverse function relationship, that f of g of x is equal to x, that's true for all inverses, I can take the derivative using my chain rule, and then solve for g prime. So it's just g prime is 1 over f prime of g of x. Let's see how they might push this a little bit further. So with somebody sitting near you, see what you can do with model problem number 2. F be a differentiable function. Differentiable just means derivative exists such that f of negative 4 is equal to 12, f of 9 is equal to negative 4, f prime of 4 is equal to negative 6, f prime of 9 is equal to 3. Whew. G is equal to f inverse of x. Oh, good. Inverses. Inverses make me happy. What's the value of g prime of negative 4? They gave you all this information about f, but they want to know about g. What's that relationship? They gave you information about f, the function, here's all, I know all the things, but they're asking me about g, and that's the inverse. Aaron, what do we know?
G prime of x equals 1 over f prime of g of x.
G prime of x is always going to be equal to 1 over f prime of g of x. If they're inverses, this has to be true. Either memorize this, or know that you start with this relationship f of g of x equals x, chain rule it, and solve it. And honestly, like in my old man brain, that's what I wind up doing because I'm not good at memorizing things anymore. But what am I after? I want g prime of negative 4. How do I get g prime of negative 4? I need 1 over f prime of g of negative 4. What's g of negative 4? Who knows what g of negative 4 is? Don't call it out. What's g of negative 4? They told it to you, just not in the way you're looking for it. Myra sees it. I think Celeste is having an epiphany here. They have told you what g of negative 4 is, but you need to remember this inverse relationship. Remember the beans? F sends domain over to range. The inverse sends range back over to domain. What's g of negative 4? Where did they give it to you? Myra, where did they give it to you? If f of 9 equals negative 4, 9 is the input, negative 4 is the output, g of negative 4 is going to be 9. So what you've got here is 1 over f prime of 9. Hey, good news. We know what f prime of 9 is. F prime of 9 is 3. So we've got 1/3. How many guys honestly have 1/3? I got 1, I got 2, I got 3, I got 4, I got 5. Okay. Now be careful. That's not the end of the question. What does this tell you about G?
That it increases.
Oh my God, on a Monday morning!
G of x increases.
Okay, because G prime of negative 4 equals 1/3, which is positive. Stephen, what were you trying to tell me?
G of x is increasing.
G of x is increasing
At x equals 4.
at x equals negative 4. Everybody okay? Really, it's about using this new derivative rule and all those inverse things that you know. All right, with that said, I think that was the last model problem. You guys have some opportunity for practice. There's 6 multiple choice questions. You have the next 13 minutes. Your goal is to get through as many of these as you can. You don't have to do them in order. I'm going to deliver the cups. Whoever's birthday is closest to a very important date, October 27th, you're in control of the cups. Everyone understand the importance of October 27th? It's my birthday. It's a very important date. So whoever's birthday is closest to October 27th, you are in control of the cups. October 27th, you can have things mailed to my home.
Well, we're not going to see her on Thursday.
5150 Grape Street, Houston, Texas, 77096.
It's the 8th, right?
Amazon delivers on Saturday. Keep working.
You will be delivered to you.
And it's actually a Thursday.
We're talking about it.
We're talking about it, but okay.
Okay.
It's all perfect, okay.
I'll just be standing at the door with my arms wide open. Here, I'll get back.
It's just basically just asking, is this asking
Okay,
is this asking the inverse of 2? Is this asking the inverse prime?
The inverse derivative.
So it's like asking, it's like if this was,
Yes, it's exactly like that.
okay.
Right? They are not going to lock themselves in like it's always F and G. It's not going to be F and G all the time. Poor Lewis. Just hear his GPA going down right now. Nothing to see here, Carmen. Nothing to see here.
I'll go to side 2.
Right?
Sacrilege, isn't it? so sorry for tearing this beautiful poster.
Where? Where did you get it?
So now I think I owe you lunch and a dessert of some sort. Cool! I think I did that.
You what?
Wait, is this right?
Do you think I just have all these things memorized?
Yes.
Okay, H prime, we found it before. Did you ever find it?
No, I did G of 2, because G of 2 is 1.
G of 2 is 1.
And I plugged in H of 1, which is 1/2.
But it would be really nice if you were plugging it into H prime, since that's even what you wrote. Oh.
So I got the derivative of that.
I know, that's what that
Ah,
prime, that's what
okay,
that little
I did
stick
math.
means.
You didn't know?
Yeah, I did that.
He would use the chair that's missing. Okay.
Oh, be careful now.
Oh my god. You're doing like all the things.
That's the
This might
mistake.
even be like lunch for a friend too. I do not. Yay, Aaron, we're so proud.
You always have a headache.
I know. It's his fault. Thank him.
Mr. Lake, can I move your domain restrictions in favor of some derivative rule stuff?
Yeah.
Like move, not get rid of.
Yeah.
Which one are you doing?
Oh, when
How'd you do that?
I like how she went.
I forgot different of meaning.
Differentiable means it means it exists.
Carmen,
It is just
it
there.
looks like you got
It's
it.
chair.
Started cutting food.
Can I read it?
Yes.
Should I try key? Yes. Do you remember? Alright.
Wait.
Alright, friends, how are you? What do we get for the first one?
On. I've got.
Alright, so we've got foldables for Aaron, I remember, and Myra, and Celeste. Okay, any foldables over here? Okay, any foldables over here? Carmen,
So,
Andrew,
that's basically good.
and my foldables are not good enough for Steven. Okay.
Yes, they are.
Alright, so which ones are we ready to check?
Knocking out the That's right. Oh, there's an answer. Like,
No, I'm not angry.
I'm sorry.
Okay. You don't agree with the number one.
What'd you guys have? Did you guys have E?
Oh, the.
You guys forgot the one over here.
I don't agree with either reaction. Okay, first of all, you're not labeling stuff. What is it? It's the prime of x. Okay, so if f prime is 2 plus e to the x, what's f prime? 0.
Alright.
Ah, bye-bye. All right, friends back here, which ones are you ready for me to check? The first 3. So number 1, we've got...
You guys didn't solve it. You
Okay.
guys didn't solve the problem. You put the equation as the x there.
Okay, I've got about 5 more minutes. I want you to at least get 4 of these problems done. 4. Mm-hmm.
What wasn't 1? That doesn't make sense, Mark.
No.
No, it's not 1.
It's still wrong.
But f of 0 equals 1.
Come on, let me read it.
So g of 1
1 equals 0.
That's how inverses work.
That's why you get. That's why the reason they got.
Yeah, because
What?
g
There's 1 over here.
Well, I mean,
your source is incredible.
That's why.
What? That's clever.
it says devil on it. People say that it's a lot.
I like it. Love it.
It's not B. I mean, it's not A. I thought B was like this.
Yeah, you.
This is G and 0, right?
Yeah. When you play.
That's wrong. Can you know that's fine? She got confused the crap out of me. So I wrote that very. Wait, that was an insult.
No.
Oh. Oh, that one.
Right, and now we start getting into the world of like, wait a second, it's not F and G anymore. It's like H and something else. It's J and something else. If you need to, David, I would not blame you if you're like on a problem like number 4. When I first saw it, I'm like, oh no, we're not gonna call that H. That's F. I'm not gonna deal with H inverse. That's G.
Is that GT?
And just kind of like do that substitution.
What is GT equal? H of 1.
All right.
Right. G of 2. H of 1 equals G of 2 equals 1. Go.
All right, friends, time is up. I know you did not get a chance to do all 6, but I need the last 15 minutes to push the thinking even further. Number 1 should be B. Number 2 should be C. Number 3 should be E. I know a lot of folks got through those first 3. Mostly doing okay? Really, it is just a matter of you need to know that new derivative rule, g prime of x equals 1 over f prime of g of x. I want you to know where it comes from. It comes from this inverse relationship. But if it just winds up being something that you memorize for that one question that's going to show up, that's fine too. All right, number 4, B. Number 5 should be D. And number 6, if anybody made it over there, A. How many guys got at least 3 of these right? Okay, so we're in a good place. If you didn't get to the 3 out of the 6, I'd at least make sure that you like indicate what the right answer is so that you can work on these later on. Now here comes the push. And I'm excited, I am eager, I am optimistic. This is not something I've normally had the pleasure of doing in a Calculus AB or even a Calculus BC course. I need you to go way back in the brain to like 2 weeks ago when we were just studying Unit 2, which was the derivative and all those derivative relationships. The AB kids' panic levels are starting to increase as they get ready for like F prime, F double prime, antiderivative kinds of stuff. You guys are pros. So here I have for you the graph of the arctangent of x. Now, any of you that have watched the derivative foldable video, you already know what the derivative is. Don't ruin the fun. What I want to do is have a conversation about the graph of arctangent of x and what that must mean about the derivative of the arctangent of x. We've been here before, you know how this works. I'm looking for things that you know about arctan and what it tells you about the graph of the derivative. Take 2 minutes with the folks around you, have some conversations, jot down all the things you know. And I should have included it in here, and I'll add it to the handout that the AB kids see. The arctangent graph has 2 horizontal asymptotes. Where are they? Anybody remember where those 2 horizontal asymptotes live? Nope. Okay, one of them is y equals pi over 2. The other one is y equals negative pi over 2. Okay. What's something that you guys know for sure about the graph of f? Okay, f is always increasing, that's for sure. So what does that tell us about f prime? F prime is always positive. What else? Anything else that you guys see?
What are you gonna do?
We have horizontal asymptotes. What does that mean about the derivative? The derivative is going to approach 0. Okay, friends back here, what are some things that we've seen about the graph?
What does that mean?
We do like the simple
Because that's how your brain works. All right, this table up front, something that you know for sure about the graph of arctan and what it tells you about the derivative. I'll take anything from anyone of the 3 of you.
Arctan is always increasing.
F of x is always increasing. We also have another word for always increasing. We haven't used it in a while, but monotone increasing, strictly increasing, these are things. If f is always increasing, tell me about f prime.
F prime is always.
F prime is always positive, okay? And Myra's team, something you know about f, what does it tell you about f prime? As f of x gets closer to 0, the slope gets steeper, and then what?
And then after,
Yep.
f of x is 0, it gets gradual.
Okay, the slopes get gradually smaller. Okay, I don't know that I necessarily know how to write all that up, but I completely agree with you. Andrew, what else do you guys have back there?
That it's concave up.
F is concave up. I love the fact that you're telling me about concavity. Where's F concave up? Concave up, that cup that holds water at 0?
Negative infinity.
From negative infinity to 0. F is concave up on the interval negative infinity to 0, so F prime. If F is concave up, the thing that we know about F prime is increasing on the interval negative infinity to 0. We could also say that F is concave down on 0 to infinity. So F prime is decreasing on the interval 0 to infinity. Okay, those things are all true. If F is concave up from negative infinity to 0 and concave down from 0 to infinity, then at x equals 0 we have a... F is concave up from negative infinity to 0. Concave down from 0 to infinity. F has a point of inflection. Has a POI at x equals 0, which means that F prime has a relative, it could be a relative max or it could be a relative min. We should know better. If I'm changing from concave up to concave down and my derivative changes from increasing to decreasing, then F prime has a relative max at x equals 0. The only thing we haven't really talked about that I think is important, David?
F of x has horizontal tangent line.
Not horizontal tangent line. Asymptote. So I could say, like, as x approaches infinity, f of x approaches pi over 2. That's a way to write horizontal asymptote. If that's true, what's true down here? As x approaches infinity, f prime of x approaches 0. And that kind of gets to Myra's point earlier that the slopes were decreasing. They were getting closer to 0. And I could also say as x approaches negative infinity, f of x approaches negative pi over 2. So here, as x approaches negative infinity, f prime of x approaches 0. I need a graph that's always positive, increasing on the interval negative infinity to 0, decreasing on the interval 0 to infinity, has a relative max at x equals 0, and approaches 0 at the ends. I think you guys know a parent function that does this. I know you know it already. David's got good curves. Or one good curve. Don't agree with you here. Because the graph of f doesn't have any vertical tangent lines. Right, I guess we could also add on here f is always differentiable. If f is always differentiable, what do we know about f prime? If f is always differentiable, f prime is always going to exist. F prime of x is continuous. What I've seen on just about everybody's paper is something that looks like this. I have to approach 0 as I approach negative infinity and positive infinity. Max at 0, always above the x-axis, increasing towards 0, decreasing after 0. You guys know what function that is. Should be something that looks like this. And this parent function? This is 1 over x squared plus 1. So our best guess is that the derivative of the arctangent of x is 1 over x squared plus 1. It is true. Now, just like before, that's not a proof. This doesn't count as a proof of anything. This is just graphical evidence. here's the proof. So I'm just gonna do the proof over here. Stephen, can the friends at North Central see from over here?
Yes.
Okay. So here's the actual proof. Let's start with f of x equals the arc tangent of x. Arctan is an inverse function. It's the inverse of what function? Tangent of x. So g of x is the tangent. I don't know the derivative of this guy here, but we do know this one here. We know what the derivative of tangent is. What's the derivative of tangent?
Secant squared.
Secant squared. Now, bad planning on my part. If tangent is the function that I know, and that's the one I know how to work with, generally I'm going to call that f of x. So sorry about that. Let f of x equal tangent of x. Let g of x equal the arctangent of x. Sorry about that last minute change of plans there. What I'm after, I need the derivative of arctan of x. My new derivative rule for working with inverses says to do what? If this is g,
It equals 1 over.
it's 1 over
F prime.
1 over f prime of g of x. F, the function that I know, has a derivative that I know. It's secant squared. F prime of x is secant squared. So what I want is 1 over the secant squared of arctangent of x. We're done with the calculus. David, hold on, you're going to be okay. We're done with the calculus. There's no more calculus here. All I need is your strong knowledge of trigonometry. You're like, why, God, why? Why can't it just be my knowledge of calculus? So here's the thing. When I say arctangent of x, well, this is just an angle, right? I'm calling theta my arctan of x. What I'm looking for is an angle that when I take the tangent of that angle, I get x. That's what we mean when we say arctan. What angle do I know of that when I take its tangent gives me x? My advice, make a triangle. Make a right triangle that when I take the tangent of angle theta, I get x. Well, how do I find tangent? I know, it's tough for a Monday morning. Tangent is opposite over adjacent. Give me side lengths that will get me x as the ratio. Don't overthink this.
Oh.
If tangent is opposite over adjacent, then opposite is, how about call the opposite x and the adjacent? 1. Now you might be like, well wait, that's not on the unit circle. I never said this was on the unit circle. I said make a right triangle that the tangent of the angle is going to be x, opposite, adjacent. Anybody know how long the hypotenuse is? X squared plus 1 squared is not the length of the hypotenuse, because you're forgetting something important. Square root.
Oh my boy.
Pythagorean theorem says a squared plus b squared equals c squared, x squared plus 1 squared equals this guy squared. Take the square root. The derivative, and I'm kind of being a little bit messy here, my apologies, as 1 over secant squared of my angle. How do I find secant? The secant of an angle says secant, show, shot. It's hypotenuse over hypotenuse over adjacent. So this is 1 over hypotenuse over the adjacent squared, because it's secant squared that I'm after. Square root of x squared plus 1 over 1 is square root of x squared plus 1. Square root of x squared plus 1 squared is x squared plus 1. If I trace this all the way through, the derivative of arctan was 1 over this f prime of g of x thing. The work that I did over here in the purple was to like be able to construct a triangle that satisfies this relationship. 1 over secant squared of that angle gets me to 1 over x squared plus 1. So your new derivative rule is that the derivative of arctangent of x is always going to be 1 over x squared plus 1. Done. If you understand and appreciate the proof, great. If you're just going to accept this blindly, I can deal with that too. Tomorrow, derivatives of arcsine and arccosine coming your way. Woo! See you later. Oh, no, David. No.
I told my ambition that I was like calculus.
Come on now. Come on now, Eileen.
Grit his teeth and
I
said,
mean, you
what?
said you were gonna read it.
Come on now, Eileen.
He said, ooh, you're smart and good looking and athletic. Thank you. That's right.
I believe 2 out of those 3.
2 out of the... I love that game, that
That was
2 truths and a lie.
That's still.
I was gonna ask you.
It's
I
in
only
the first
drew
5
like-
pages of Cold Blood.
Was it really? Oh.
Yeah. He told me on Schoology.
Later.
Sign up for that class.
Oh, need a few minutes to.
Yeah, if you don't mind, if I can get that video rock and rolling.
No, it's good for me. Finish this.